Hey everyone, my name is Rob, and in this video I'm going to show you how you can use machine learning to create your very own March Madness bracket and beat all of your friends and make them all really jealous of you. So if you want people to be jealous of you and you want to learn about machine learning and data science, this is the place to be. I'm going to be walking through some code that I've shared in the description as a Kaggle notebook. So you should be able to just copy this notebook on your account and run through the code all yourself. We're also going to be running this code using cuDiff, which allows us to run pandas on GPUs. That way our code can run faster. Now maybe some of you out there don't have a GPU. Well, you're in luck, because I have here a brand new 4080 that I'm giving away to one of my subscribers. So check out the description where I have a link which will show you how to sign up for NVIDIA's GTC conference that you can attend virtually for free. And I'll be picking one of you randomly that will be sent this GPU. All right, so here we are in the Kaggle notebook. Now the cool thing is that Kaggle has hosted NCAA tournaments for many years. So they provide all the data and historical data about each teams that we're going to use in order to create our model. Now I'm here in a Kaggle notebook, and I want you to notice that I'm running a session that does have 2 GPUs enabled, and we're going to use that when running our pandas code. All you really need to know about this is that it's installing the version of cuDiff that we need in order to get pandas to run seamlessly on our GPU. Now here I'm also installing Jupyter Black. This will automatically make our code formatted correctly and look pretty. And XGBoost, which is the model type that we're going to use to train in order to make our predictions about the NCAA tournament. And now let's check to make sure that cuDiff is working. cuDiff is what allows us to run the pandas code on our GPU. I'll show you up here again in the top corner that we do have these 2 GPUs, and they're not really being used yet. But when we load in our data after running this extension, we don't really have to modify our pandas code at all, and it should all run on the GPU as if it was on the CPU, and essentially just be faster. Now here you can see I'm importing some of the packages that we'll need to run our analysis here. I've also imported XGBoost. That's the model that we're going to be using, and some of the metrics that we're going to use to evaluate how well our models. Before we start modeling, we need to have some basic understanding of the data. I'd recommend you do some exploration on your own. We're not going to do much of that in this video, but it's really important to have a good understanding of what the data looks like before you start modeling. Because I've linked the data already to this notebook, you can see it's over here on the right side. And that data actually sits in this input directory under March Madness Machine Learning Mania 2024. So here I've just listed out all the files that we have. There's actually a lot more data than we're going to need to use to create this baseline model, but some of this you might find interesting to explore or to use to create a better model. So out of all these files, we're going to focus mainly on the regular season results, and we're going to use the compact results that have less details than the full-fledged detailed results file. We're also going to use the results of past tournament games because those are going to be used as our ground truth that we'll train our model on. We also need the tournament seeds, which I'll show you how we'll use later. And then this 2024 seed CSV will eventually have the tournament seeds for this year's tournament. At the time of recording this video, those haven't been announced yet, so this is just a placeholder with the 2023 tournament seeds. To make things easier, I'm just defining a variable, which is the data path that all of this data sits in. Okay, so here I'm reading in those 3 main files that we had talked about before. Now, since this data set has both men's and women's tournament data, we're going to read in both at the same time and concatenate those together. So you can see here as I'm reading the seeds data, the season results, and the tournament results, reading both the men's and the women's CSV for each. Then I'm assigning a new column to each of those that designate which league they're in, the men's or the women's. So just to show you, here's the data frame with the seeds. It has going back to 1985, each seed in the tournament, and then the team ID, and this new league column that I created to show you if it's the men's or the women's league. The season result data set has one row for each game played in each of these past seasons. And you can see that there's the winning team ID, the losing team ID, and the tourney results data frame is similar to the regular season results, but it has all the results that occurred within the tournament. So we're going to use this to define our ground truth data that we'll train our model on. Before we go much further, let's think about how we want this data to be formatted in order to train our machine learning model. Right now we have a bunch of data about the teams that occurred in the regular season, and we also have the results from past tournaments. What we want to have in order to train a machine learning model is a data set with one row that has each game that occurred in the past tournaments. And then we want to have features about each of those teams. And those features are going to come from the regular season, like the team's winning percentage and their average margin of victory. Once we have those features and target together in the same data set, we can start training our model. So we're going to go about this in 2 steps. The first step is by taking this regular season data and actually making it so that we have one row per team game that we have. If you remember here, our season results data frame has one row with a winning team and a losing team ID in each of them. But what we actually want to have in order to aggregate this data per team is a single row per team and then the opponent team that they played against. So we'll actually have 2 rows per game that occurred in the regular season, one with each team being the main team, with the other team being the opponent. And that's what I'm doing here in this row. This looks like a lot, but let's break it down. We're taking the regular season results and first looking at the winning team, and we're just renaming it to team ID. And we're also adding a new column that indicates that this team did win. Now after that, we're taking all the losing team IDs and we're creating an identical type of data frame, but now the losing team score is going to be that team score and the opponent's team score is going to be the winning score. We're then concatenating these 2 data sets together. And if we look at it here, we have now data set which has a team ID instead of a winning and losing team ID, the scores, and then this game result column. This is great because now we can aggregate this data by the team ID and create some features about the team's regular season performance. But before we aggregate this up per team, we're also going to create the score differential between the 2 teams. So if you see our regular season results, we have the team score and the opponent score. We can create something called the score differential by simply taking these team scores and subtracting the opponent's score. I'm just going to sample 10 random rows to show you what this looks like. So in this case, we have a men's game where the score differential was negative, which means that the team ID that we're looking at lost that game. And any time where the score differential is positive, then the team ID is the winner of that game. Great, now we have a data set where we have one row per game played by each team for each regular season game. And now we can aggregate to the team season level and create some features about that team. We're going to call this new data frame team season ag for aggregation. And you can see here, we're going to group by the season, team ID, and league and create our aggregations. We're going to take the average, median, min, and max score differential for the team in that regular season. We're also going to count the number of wins and loss the teams had for that regular season. And we're going to create a win percentage, which is just the number of wins divided by the total number of games that they had in the season. Now, if we look here at this data set, we can see now we have only one row per season team ID, and we have these aggregated features like the average score difference, the number of wins that they had, and their winning percentage in the regular season. And we're going to use these to create our model. Now, one thing to note is we're using the compact regular season results, which are very basic results from the regular season. But if you wanted to go into the detailed results from the regular season, you could pull out even more granular and detailed features like the number of three-pointers made or free throw percentages if you think those are interesting and would help out your model. But we're going to keep it pretty simple here. Now remember, we also have this data set with the seeds of the teams playing in the tournament. And we're actually going to use those seeds as features that we can use in our model. And then you could see the seed actually has a numeric value for which are the 4 regions that they played in, and then a numeric value that has the seed that they are between 1 and 16 for that region. And we're going to use that by extracting it out. That's essentially what this line does. It creates that chalk seed that I'm calling. And the chalk seed is just a number between 1 and 16. If a team is a number 1 seed, they're expected to be a better team than a 16. And we're going to merge this onto our team season aggregation, which now gives us this chalk seed and seed column. Now note, this only shows for teams that made the tournament, since many of the teams that play in the regular season, we've aggregated their data, but they didn't play in the tournament. So if you're wondering why a lot of these values look like they're missing, that's why. So that's step 1. We've finished aggregating the regular season stats. Now we're going to do the same thing with the tournament results. Now, if we look here at the Tourney results file, it's very similar to our regular season file where we have a winning team ID, a losing team ID, and then the scores of each of those teams. But similar to like before, we actually want to have the data in the format where we have 1 row per team ID and then their opponent team ID. It's essentially the same thing as before. We first focus on the winning team ID and we add a new column that's called game result equals win. And we rename these columns so that we have just 1 team ID and then their opponent's team ID. We do the same for the losses. If we look at the data now, we have 1 row per team that played in a tournament game. And we have the game result if they won or lost, and some information like the team score. So we've completed step number 1, which is aggregating each team's metrics that occurred in the regular season, like their winning percentage and their margin of victory. And then we've done step number 2, which is modifying the tournament results into a format where we have 1 row per team that played a game. So all that's left to do is merge those 2 data sets together, and we'll have both our features and our target, and we'll be ready to train a model. But actually, we're going to merge our team season data onto this data set twice. Once for our main team ID and once for the opponent. And the way I've merged this, we have some metrics for that team, like their winning percentage and their median score differential, but we also have that for their opponent. So we can use this to create even more features like the difference between each of those 2 teams. So just to show you, I'm taking something like the win percentage of the team ID 1, then I'm subtracting the opponent's team win percentage, and we're just creating a new feature called win percent difference that we'll use to train our model. If I print out the columns in our data set now, we have our target, which is if the team won or not. And we also have all these features that we've created, like the difference in the team's regular season performance, the difference in seeds. And these are really the features that we're going to use to train our model with. And we're going to add one more feature from an external data set that has ended up over the years being really powerful. And those are the team scores provided by the website 538. They do their own analysis to create evaluation of each team going into each tournament. And people have saved these off going back to 2016. So we can actually use these features as inputs to our model. It's almost like a stacking of models where we're trying to make our model better by using a different model's results. Now, the downside to this is it only goes back to 2016, so it limits our training data to 2016, but the benefit that we get from it is pretty strong, and we're going to add them. So I'm combining the 538 scores like I did all the other data sets we imported. And you can see this data set is pretty simple. It just has for each season team ID the rating that they were given by 538. Now, in order to use these features in your model, you'll need to use the latest 538 ratings for this season. And since those haven't been released yet, you may have to look around the Kaggle forums for a data set where someone's uploaded those. Now we're going to take our historic tournament features. We're going to merge on these 538 scores so that we have them added to our data set as a feature. And we merged on those scores for both the team ID and the opponent team ID. We'll again take the difference between those as a new feature that we can use in our model. To show you here, I've subsetted just to these 538 columns. You can see the difference in these 538 ratings is this new feature that we've created called 538 rating diff. So we're almost at the point where we're ready to train our model. But before we do that, it's a good idea to get a good baseline. Because even if we create a model that has a certain score, we don't know how well that does against just picking the higher rated seed in the tournament. So we're going to go ahead and do that as our baseline. And we'll do that by looking at the seed column. We'll just assume that if the chalk seed is less than the opponent, that the team will win. So essentially the higher rated teams will always win until the final four. And since that only works all the way up until the final four, which potentially we would then have all the number one seeds facing off, for the final games, we'll just use the team's win percentage to determine those last few games. After doing that, we now have a new column called baseline prediction, and we can use that baseline to score how well we did since we know the actual outcomes of each of these games. And these are just binary true or false predictions. Because our model will produce probabilities, we're going to evaluate it with something like log loss. But we're also going to take a look at just simple accuracy, and we're going to do that season by season. So what I've done here is we're iterating over each unique season in this data set that we've created. We're creating our predictions, which is that baseline, and then our ground truth, which is that win column, calculating both the accuracy and the log loss score, which we'll print out. And we'll also print out the average accuracy of this baseline prediction across all of the seasons we have. So there with our baseline predictions, we have a baseline accuracy of 0.72. If our model can't beat that, then our model's not very good and we should just pick the better rated teams for each round. But hopefully we'll be able to beat that with our machine learning model. Other thing to look at here is the log loss scores, which actually doesn't tell us too much because we're predicting that binary 0 or 1 for these predictions. But these log losses will make a lot more sense when we're using our model, which actually will provide a probability for each of the game predictions. So now we have a baseline that we're looking to surpass with our machine learning model. It's time to use XGBoost and train some models and see how well it performs with these features. It's very important that we create a validation strategy that'll work well for us. And in this case, I'm going to actually use a leave one season out validation approach. What this does is we're going to iterate through each of the seasons that we have data for and hold it out to evaluate how well our model does. It helps us to avoid overfitting our model to the data we have, especially with small data like this. This is very important. We can do many things like changing the parameters of the model or changing the features that we have in the model and try our best to make that improve this overall validation score. So here I'm defining the features that we'll use for our model in the target column, which is if the team won or not. These are the features that we spent all that time creating. And I've actually commented out many of them because in most cases, less features actually works better. But this is something you can experiment with on your own. So we're really only using 3 features to predict this target win. And we're going to create an X, which is our feature variables, and a Y, which is the target, based off of our historic Tourney features data set. Then we're going to do our group k-fold cross-validation, where we'll train with one season's data held out. And that's what this loop does. We're looping over each of those seasons, and we're subsetting to a train and test, or I guess you could call this a validation set that we'll score a model on for each of those seasons. I'm creating our model here, and it's an XGBoost regressor. I found that regressor works better than the XGBoost classifier, but you can experiment with that on your own. I've also increased this number of estimators parameter. It essentially is the number of trees that this gradient boosted tree algorithm will create. And then I've decreased the learning rate so that it'll learn a little bit slower, but it may get a better result in the end. Then here I'm running a model fit on the training data, and I'm keeping the evaluation data here as an evaluation set and having it print that log loss metric every 100 trees that it creates. That way we can see if the model is actually getting better on that holdout set as it creates more trees. This is another way just to see if the model is potentially overfitting. Then we'll predict for that season on the test set, we'll score it, we'll print out the results. Another thing to note here is I've created a list here called models, and we're appending each of our models to that list. That's because we're going to be using those models to make our final predictions on this season's tournament data. All right, so let's go ahead and run this, and we can see that for each season, our log loss is becoming less the more it trains up into those 1,000 different trees that it'll create. And then I've printed out the season's accuracy score and the log loss score. In the end, we want to make sure that our total accuracy has improved off of that baseline. And we can see here it has. The average accuracy of our model is 0.733. So this might not seem like a huge improvement off of our baseline, but really any improvement we can make is good. And you can, like I said, mess around with different features and different parameter tuning to see how well you can get this score to increase. So the last part here is taking those models that we used in our cross-validation loop and using them to predict on our test set. So we don't have at this moment the new 2024 tournament bracket released yet, but this code is what we'll use in order to do that on 2024. A few things to note are just that you'll want to change this 2023 test season to be 2024 once it's released. So once those new seeds are released, we'll change this to 2024, and we'll make sure that this Tourney seed CSV is the new updated one. So this is what our seed data looks like. We have the seed and team ID for each team in the tournament. Now, one thing to keep in mind about this seed data is we don't actually know which teams will play each other in later rounds of the tournament. So what we're going to do is create a new data set with every possible combination of teams that could potentially play each other in the tournament. And then we'll use our model to predict for each of those games. And I'm calling this the tournament pairs data frame. And you can see here I've created it by merging the seeds 2024 data on itself. And then I'm removing any rows where it has a team playing itself, since that's not possible. The rest of this is pretty similar to what we did before, where I'm adding in all the aggregation data, creating this chalk seed, and then adding in the 538 ratings, and then creating these diff features, which are the difference in metrics between the two different teams playing against each other. So if I just show the first 5 rows of this Tourney pairs, it should have all the same features that we created before. The only difference being we don't have that ground truth label of if the team won or not. Now, if you remember, I saved away each of the models that we trained before into this models list. We're now going to loop through each of those models and make our prediction just like we did before, and store that off in our Tourney pairs. So you see after I ran this, for each of these pairs, we have 7 different predictions that each of those models made. Then I'll just simply average the predictions made for each of those models. So I'm subsetting to all these prediction columns. And when I subset to them, I can just run .mean with the axis equals 1, and that'll create an average prediction from all of those 7 models. I'm storing that away in a new column called pred. So at this point, we have pretty much everything we've been trying to achieve. We have a prediction for every potential matchup in the tournament, and it's a value between 0 and 1, the probability that the model thinks that this team ID will beat the opponent team ID. But if you're looking to actually make a bracket out of this, you need to run a simulation with these predictions to wind it down to that standard bracket that you're used to using. Luckily, someone on Kaggle already created code that will do this. It will go through each of the seed probabilities that we have and determine what your bracket should look like based on these probabilities. So I'm not going to go into too much detail about this code, but also know that this allows you to simulate more than just one bracket. And this might be helpful if you're trying to submit to the Kaggle competition, which allows you to submit thousands of different brackets and be scored on all of them. And I'm actually saving out this output in the format that the Kaggle competition would take. But if you're just someone looking to fill out your own bracket, you're probably more interested in the team names than you are in the team IDs. So here I've taken in the team name data set and I've merged it on with our predictions, and that's it. We have our actual predicted team names for each round of the tournament. And I've saved this off as a CSV that you should be able to load in Excel. And then all that's left is to take what we have here and to fill out your bracket for each of the rounds here. If you watch up into this point, then now you know how to use machine learning to make your bracket predictions that much better this year. Also keep in mind that all the processing and modeling that we did today took place on a GPU, which makes things a lot faster than if you were to run this on your local CPU. So if you enjoyed this, write a comment below and tell me who you think is going to win the tournament this year. See you next time.